This is the last section of this chapter. Okay, it's a little shorter of a chapter, so that's good. We're going to change that test from Friday to Monday since we took a little longer yesterday. All right, so we'll take the test on Monday. I hate to give tests on Monday, but that's just the way it works out. All right, so we'll take the test on Monday. All right, so 11.5. Let's do this. What I'm going to do, you could have any polygon here. It doesn't make a difference. I just chose one that looks like this. Kind of looks like a trapezoid. Doesn't have to be a trapezoid. I just picked one that is. Watch what I'm going to do though. I'm going to copy it. I hit Control C for copy and then Control V for paste, right? You ever do that? No. If you ever do any desktop publishing or anything like that, it's kind of a universal thing. Almost every program, you hit Control C to copy, Control V, which is right next to the C. That's why they picked V, all right, is to copy. Nobody's ever done that before? Okay. I right click. All right. You right click or you go up to the thing up there. I love the keyboard shortcuts. The more of those you learn, you don't have to move your mouse way up here and select all this stuff, drop down menus and all that. Anyway, so this is an exact copy. This one right here is an exact copy of this. But watch what I'm going to do. Here's another desktop publishing trick. If you hit the Shift key, and like if you're putting pictures, if you're doing a project, even in Word and stuff like that, if you're putting in a picture, if you just take one of the corners and not click anything and you move it, it changes the proportion of it, doesn't it? See? That is not similar to this anymore. Alright, so what I'm going to do, how do you undo? What's the keyboard stroke for undo? Control Z, right, that's a lifesaver. Almost every program that you're going to work with, which is desktop publishing or stuff like that, Control Z undoes what you just did. So if you made a big blunder, as long as you don't click anything else, you hit Control Z, it'll go back to what you had. So that's a lifesaver sometimes. Watch what I'm going to do. To keep it in proportion, you're right, I'm going to hit the Shift key. I'm going to grab a corner. So right now I'm hitting the Shift key. I know you can't see that, but I am. And then look what it does. See, even if I move this mouse up and down like this, do you see it? Okay, it still keeps everything in proportion. So if you're doing a project, you got to put pictures on there, and you have a certain spot for it, don't just take a corner and just drag it. You ever do that in your projects and people look real skinny or they look real fat and stuff and you're like, oh, you know, whatever. And I hate when people do that kind of stuff because it's not in proportion, especially for photos. They need to be in proportion. So, you know, and you know I'm a photo guy, so it's got to look like that. So what do we have right here? I hit the Shift key and I made this, and what are they? They're similar to each other. We had a whole chapter, didn't we, about things that are similar to each other. So right now we know that these two things are similar to each other. Let's just do this. Let's call this A, B, C, D. Tell you what, I'm going to throw something at you that they don't do in the book here, but I saw for the first time in college. It's kind of a nice way to do it. Instead of calling this A, B, C, E, F, G, H, instead of doing that, watch this. This will throw you for a loop. I'm going to call it A prime. That little dash right there means A prime. Basically, it's like having another letter, but you can see which ones relate. See, the A prime goes with the A. Isn't that a nice way to do that? So instead of calling it E and saying A and E are equal to each other, we just say A prime. Is that okay with you? It's just like having another letter of the alphabet. It's like having a whole new 26 letters to work with. All right, so if I call this A, I'll call this A prime. What do you think I'll call this angle right here? B prime, and then C prime and D prime. Is that all right with you? They don't do that in the book, but they do that in college a lot, and I think it's a nice way to do it because you can very easily tell which angle is equal to what. If I say what's equal to angle A, you would say what? A prime. Easy enough. Make sense? Okay. So that doesn't bother you too much, does it? Okay, I don't think it should. All right, so what we have is we have two similar polygons. What we're going to do is talk about the area of these polygons. Okay, and here's a little formula for this. I'm not going to go through and show you why, but let's do this. If I compare the area to both of these, so let's just write it like this: the area of polygon ABCD, ABCD. And if I compare it, or I divide it by, right, I'm making a ratio out of this, so I'm going to have a proportion, right? You remember with similar figures, you did proportions all the time, you figured out scale factor, you figured out ratios, all that kind of stuff. So this is the area of ABCD. If I compare it to the area of the similar figure, even though it's not exactly the same, I'm doing a comparison. So I'm going to take the area of A prime, B prime, C prime, D prime. Okay? So if I compare those to each other, what that's equal to, it's equal to the square of their, oh, I just said it, the scale factor. All right, the scale factor. So what would the scale factor be? It would be if I compared AB to what? A prime, B prime, right? Let's just do it like that. So watch, if I compared AB to A prime, B prime, see what I did? This is the area of this. If I found the area of this and I compared it to the area of this, so I took this area and divided it by this area, it's going to equal not this side divided by this side. Okay, it's this side what? Squared divided by this side squared. So this is really a scale factor. Alright, so the proportion of the areas is equal to the square of the scale factors. You hear what I said? It's the square of the scale factors. It's not just the scale factors. So if I knew the area of this, and I knew the area of this, and let's say I knew the length of that was 5, I could find the length of this right here by putting into this formula. So this is your formula right here. So you just compare the two areas to each other, and then you compare the scale factors to each other. Right? One side to its corresponding side. I didn't have to pick AB and A prime B prime. I could have picked what else? I could have picked AD and A prime D prime. Okay? Does that make sense? Is that what you're going to ask? Okay. Yeah, I could have picked any of those. Okay? I didn't have to pick AB. I could have picked any of the scale factors. Now, I could not compare this. I couldn't compare BC to D prime C prime. Does that make sense? All right, only the ones that are proportional. Only the ones that, yeah, are proportional to each other. Travis?
Are the angles the same?
The angles are still the same, yeah. But that really doesn't have anything to do with this formula right here. Okay, we're just talking about the lengths of the sides and the area, okay, of the two figures. All right, does that make any sense? So if I know the area of this, or if I can figure out the area of this, but let's say they tell me the area of this thing, right? And then they tell me the area of this. And if they tell me one of these sides, all right, I should be able to find the area of this side by just plugging the stuff into this formula and then figuring it out. You okay with that? Does that make any sense? All right, so let's do an example, and hopefully that'll make a little more sense. So yeah, I'll tell you what, I'll scoot this up so we can see that formula. Okay, right there. They do a triangle this time. I'll just pick any old triangle. Here's a nice triangle right here, and we'll make this bigger. I'll tell you what, I'll make this look like the picture in the book. Alright, so if you go back and look at it in the book, you'll say, okay, that's what he was talking about. Alright, scooch it down a little bit more now. Let's try this one more time. Alright, here's a triangle, and let's make it look like they make it look something like that. And then copied and pasted. Now that's congruent to it, but if I hit the shift key, I'm going to make this a little bit bigger, like that. And they actually swing this down about like that. Okay, so that's pretty much what it looks like in the book. Alright, and what do they tell you? Let's try some different colors. I'm tired of just reading in white all the time. This is JKL, JKL. Now they don't use the prime stuff on this, but this is Q, R, and P. Alright, and they tell you something. They tell you which triangle is similar to what. So triangle JKL is similar, so you don't have to do any guesswork on this, PQR. Chandler, get your head up, please. JKL. So what does that mean? J and P are equal to each other, right? Everybody see that? K and Q are equal to each other. I don't know if it's right angle. Kind of looks like it could be, but we'll just mark it equal. And then L and R, we'll just leave those blank. All right. Let's see. What else do they tell you? They actually, oh, okay, I see. They tell you this. They tell you that that side is 12 and this side is 15. And I believe that's all they give you. Now they tell you the area of JKL. So they tell you the area of this triangle right here is 30. 30 square whatever inches. Alright? And the question is, to solve for the area of this triangle right here. Alright, so let's find the area, A equals question mark. So that's what we're trying to do. We're trying to find the area of this big triangle right here. Now look, right now we don't know it. If I just use this triangle by itself, is there any way I can find the area of it? Just this triangle by itself? No. I only know the base, right? I don't know anything else. I don't even know if this is the height, do I? Because it would be the height of his perpendicular. Do they even tell me that it's the height that is perpendicular? No, they don't. We could almost guess and say, yeah, it might be, but we don't know. So we can't even assume that this is the height, even if they told it to us. All right, because it doesn't say this is a right angle. So we're going to use this formula right here. Because look, I know the area of one triangle, and I actually know the scale factor, don't I? Look, 12 over 5. If I wanted to, I could reduce it, couldn't I? Let's compare the little one to the big one. So 12 over what? 15. What does that reduce to? 4 over 5. So the scale factor is 4 over 5. You could use 12 and 15 if you wanted to, but look, we're going to square it. Isn't it a lot easier to square 4 and 5 than it would be 12 and 15? Yeah, I think so. So let's use the 4 and the 5. So let's put this into the formula. Let's use a different color so we know we're doing something different here. So the area, let's compare the little triangle to the big triangle. Actually, I lied. Let's do this. Let's go the big triangle to the little triangle, because that will put the area on top and make it a little bit easier math-wise for us. Okay, so this is the area of triangle PRQ, or PQR, we'll call it PQR. I'm just putting it into this formula over the area of the other triangle. Now, we know the area of the other triangle, so it's 30, so I just put that right here. Make sense? Equals. Now the scale factor. Now, I went 12 over 15, which is 4 over 5, but if I'm comparing the big one to the small one, what would the scale factor be? It would be 5 over 4, that's right. So if I compare the big one to the small one, this has to be the big one to the small one. So that's got to be a 5 and that's got to be a 4. Make sense? And then we got to square it though, don't we? Now you could put that in parentheses, but I'm going to square them individually, because in algebra it says we can do that, right? I'm squaring everything in there, so I'm going to square them individually like that. All right, don't forget to square them. Okay, I almost did actually until Demir reminded me. Okay, so you do have to square those. So how do I get the area of this triangle? What do I do to that 30? Multiply it, right? It's just basic algebra, right? Multiply both sides by 30. So come over here, multiply this by 30, and then this is what we're chucking into a calculator right there. All right, so we put it in there, and that should give you the area of that triangle that we're looking for, this big triangle right here. So that's 25, right, times 30 divided by what? 16. And that gives you 46 point, let's say 9. Okay, so the area of this triangle is 46.9. Okay, and they don't tell you how to round it, so we'll just keep it like that. All right, it's in inches, so it's what? It's square inches. So there you go. Now you found the area of this triangle by using this little formula right here. That really wasn't that hard, was it? Okay, as long as they give you enough information, just plug the stuff. You got 4 things you need to know. You need to know 2 corresponding sides, right? And are these sides corresponding? Are the 12 and the 15 corresponding? You're like, well, wait a minute, that's up and down side, and this side goes across like this. But how do we know that they correspond to each other? Look to see what angle they're opposite. Look at 12. What's it opposite? This angle with no arc on it, right? And then look at this 15. What is it opposite? The angle with what? No arc on it. See the L and the R. Look where the L and the R line up. The L is last here and the R is last here. So do the 12 and the 15, are they the scale factor? Yes, they are, right? Because they're proportional sides. 12 and 15 are the ones that match up with each other. They're the corresponding sides. I shouldn't say proportional, the corresponding sides. Rachel? Because I just reduced it. 3 goes into that 4 times, 3 goes into that 5 times. Okay? Now, you could have just put 15 over 12 if you wanted to. But then you got bigger numbers. You got a calculator. It's really not that big of a deal anyway. You don't really have to reduce it. But I just did. All right? To me, it just made it a little bit easier. So, yeah, you get the same exact thing. All right? So if I had 15 squared times 30 over 12 squared, you get the same exact number. Got it? What do you think? That's not too tough, is it? Just got to know the formula, right? Just know the formula right there. So you compare the areas, compare the look at the scale factor, square the scale factor. Make sure you're comparing the correct sides. This is, I don't know, we'll call it the little triangle to the big triangle. Then this would be the little triangle to the big triangle, or vice versa. It depends on how you want to compare it. I just thought it was easier, since I'm solving for for the area of the big triangle, is to put the big triangle on the top. I think that's a lot easier that way. All right, well, there you go. If I went a little too fast for you and you didn't get a few of these steps, go back on YouTube, watch it, and pause it, and go back if you need to, and that should help you out a little bit. All right, let's do some problems here. So it's section 11.5. It's going to be pages. Actually, I'm only going to have you do one page, 805. But I'm going to have you do 37 problems. No, I'm not kidding. You believe it? When have I ever given you 37 problems to do? 6 to 13. That's 8 problems, right? There it is. Yeah, we're going to move the test to Monday, okay? So I'll write that on here. Test, chapter 11 on Monday. We don't have any more days off or anything, do we, until the rest of the year? Oh, Memorial Day, right. Is that before finals, or is that... So that's like right before finals. So as far as like regular school days, though, we're straight through, right? Until what? What's the day?
I think we have next week 5 days, and then the week after that we have 4 days, and then Fridays a half week.
Okay, so we got next week. We have all of next week, and then we have 4 days of the following week. And those 4 days are supposed to be like review days. I may not. It all depends. I may not use all those days to review because I'll probably do what I did for the midterm. Not probably, I will. I'm going to go through every problem on the test that's going to be on the final. Okay, I'm going to go through every problem, show you how to do every problem on the old tests, put them on YouTube, and that's really going to be your big part of the review. So your review will be mostly looking at your old tests, looking at me working those old tests on YouTube. What's that? We'll probably do another chapter, but I doubt we'll get through. I don't think we'll have enough time to get through the whole entire chapter, but we will do a little bit more. Maybe have another quiz or two, and that's about it. Okay? So we're almost done. Yep, that's it.